And the question is, Mavis is thinking of an interesting 4-digit number. Each digit is a perfect square. The units digit is the sum of the thousands, hundreds, and tens digit. The thousands digit is the product of the tens and... Shanya.
4149.
That is the correct answer.
All right, let us walk through this problem. Let me read it once more. The question reads, Mavis is thinking of an interesting 4-digit number, and each digit is a perfect square number. The units digit is the sum of the thousands, the hundreds, and the tens digits together. The thousands digit is the product of the tens and the hundreds digits together. Then the sum of the thousands and the tens digit is one less than the unit digit. Then what is that number Mavis is thinking? So since it is a 4-digit number, I would like to declare it with let the number be A, B, C, D, something like this, where these numbers are all perfect square numbers. And you know, example of a 4-digit number is like 2593. This is an example of a 4-digit number. You should know that no single digit here will exceed 9. So the least it can be is 0, and the highest it can be is 9. So all of them being a perfect square number each, therefore the set will be from 0, 1, 4, and 9. Yes, A, B, C, D have to be from this set. So let's form our equations. The first equation we would like to form here is the units digit is the sum of the thousands, the hundreds, and the tens digit. What is the unit digit here? The unit digit is going to be D. So D is equal to A plus B plus C according to this question. This is our first equation. And the second equation we're going to form here is the thousands digit is the product of the tens and the hundreds. The thousands is A. The product of the tens and hundreds, B and C together, right? So this is BC, product, multiplication. And the last equation we're going to form is the sum of the thousands and the tens. Thousands and the tens. We're talking about A and C, right? A plus C is equal to what? From the question, is 1 less than the unit digit. Therefore, we're going to take the unit digit, which is D, and subtract 1. This is our third equation. So let's go through the solution. From the third equation, we can make D the subject. D is equal to A plus C plus 1 if you take negative 1 to the other side. But remember, we have another equation. This is equation 4, right? We have another equation in terms of D, which is equation 1. So since all of them are in terms of D, we are going to set their right-hand side to be the same. So this implies that A plus B plus C from equation 1, right? That is the right-hand side, must be equal to A plus C plus 1 from this fourth equation. A will cancel A, C will cancel C, which implies that B is equal to 1, and we know that 1 is a perfect square number. So let us start arranging. Remember, our 4-digit number is A, B, C, D. So we have seen that B is 1. Now we need to find A, C, and D. Let's back substitute the value of B into which equation? We can plug it here. A is equal to BC, right? If A is equal to BC and B is 1, then A implies what? Equal to C. So we can come here and substitute A with C or C with A anyhow. So I would like to remove A and write it as C because they are the same. So the thousands and the tens digits are exactly the same. So what can we do to find them? Let me take this equation number 4, which is in terms of D. D is equal to A plus C plus 1, right? A plus C plus 1. But we know that A and C are the same. I have changed A to be equal to C. So this is D equal to 2C plus 1. But we know that these numbers are all perfect square numbers. And we have already seen that 1 is a perfect square number. So what if we substitute c to be equal to 1? If c is equal to 1, we have 1 times 2, which is 2 plus 1 is 3, and 3 is not a perfect square number. What if c is 2? C cannot be 2 because 2 is not a perfect square number. The next perfect square number is 4. If c is equal to 4, we have 4 times 2 here, which is 8, and 8 plus 1 is 9, and 9 is a perfect square number. Therefore, d is equal to 2 multiplied by 4 plus 1, which is equal to 9. So come here and write d as 9. But we have seen that c is already 4, right? So you bring it back here, 4 and 4. So the number is 4,149, exactly as what the contestant said. 4,149. This is our 4-digit number. Yes, as simple as that.